What we're going to do is use this stroke prediction data set and work with it in Jupyter Notebooks, pre-process the data, create some machine learning models with it, evaluate the models, and then take one of those models and use it in a Streamlit app. So try to go through this whole process from start to finish. I found this data set on Kaggle. Kaggle is an amazing resource in terms of finding data sets, finding models, finding people's notebooks. So for instance here, this stroke prediction data set. So I just searched for a data set around strokes, and there's all sorts of information about it. But down here they've got notebook. This is a great resource because you can look at what other people have done in terms of reviewing the data, plotting the data to look at it, evaluate it, and also create models. So this is a great resource for learning how to go through this process. And as well, they even give you similar data sets. So found the data set, and you just want to click here to download it. And I'll include a link to this data set in the lesson. So you'll download the file. So within my Streamlit folder, I've created a stroke prediction folder, and I've moved this healthcare data set stroke data CSV file. So that is a comma separated value file. You can open it with Excel. And you can see that it is basically a spreadsheet of information, a survey of people with different information about the people, and then it tells us it's a 1 if they have had a stroke or a 0 if not. We've got the ID of the person answering the survey, the gender, their age, whether or not they have hypertension, whether or not they have heart disease, whether or not they're married, what type of work they do, private, government job, unemployed, self-employed, whether they live in an urban or a rural setting, their average glucose level, their BMI, their body mass index, whether or not they've ever smoked. And then again, this is the target. A 1, yes, they've had a stroke, and a 0, no, they haven't had a stroke. We're hoping to put this information into an app where a person could enter this information about themselves, and then it would tell them what their risk or predict their risk of stroke based upon their information and a model that we'll create. So what we want to do is open a terminal window, and I'm going to go to my folder that I've created. And if I do a list, I've got my CSV file in there. First, I'm going to make a virtual environment for my Python. So if you remember from the last lesson, when working in Python, and since we'll be downloading potentially different libraries and packages, we want to keep them packaged together or siloed together. So it's good to create a virtual environment. Python 𝗵𝗺, and I'm just going to call this PyEnv. And then to activate my environment, I do source PyEnv, bin activate. And we see this PyEnv showing up here in front of my prompt, so we know that we are within that environment. Now the next step is to open up our Jupyter Notebook. So we just type in Jupyter Notebook. If you don't have Jupyter Notebook installed, you can do that at the terminal by typing pip install Jupyter. I've previously created the Jupyter Notebook, and I've actually got that link in the curriculum lesson. I'm going to just open it here. You should be able to open this as well. I just want to go through the different commands within my notebook. We're going to use the pandas library so that we can play around with the data set. So the first thing we do is read in the CSV file. And if you recall, this head command just gives us the first 5 rows of it. So this looks very much just like the spreadsheet that we saw. In terms of pre-processing the data, one of the things we talk about is null values. So looking here, everything looks pretty good except this BMI. If we notice, there are 201. And let's first, let's just do a df.info. Oh, so I actually have to run this. So let's just run these. There is no df until I've loaded it. There are 5,110 entries. So there's 5,100 rows in this. And there are 12 columns. So we've got the ID plus 11 features. And so now if I do this sum, it tells us that there are 201. So that's kind of a significant number of missing values. If you don't know how I got this, this is called markdown. Really, you just have to, in a particular cell, if you do, you could either do code or markdown. So to get text rather than code in a row or a cell, you can just choose markdown. So I just wanted to kind of just put some headers in where I'm doing certain things. What I'm doing here is saying fill any of the cells in the data set that are null values. And then what I'm going to do is take the median of the entire column, and then I'm just going to round that number down. And so what that says is fill any of the null values with the median value of the rest of the column. So we're just kind of taking the average and putting that in there. And then if I run this again, we can now see that BMI has 0 null values. We've filled in null values with an average of the other ones. So we can still use the rest of the data, and we're just using an average for that particular feature. And again, I've just done an info here, so we'll just run that again. And then I started to run some plots just to kind of see, in this case, what's the age range of the respondents. So we've actually got people from age 0 all the way up to 82. So that's quite a range. And then what I wanted to do is I wanted to look at some of the other features. Let me just run this again in here. So I'm hitting Shift Enter to run each cell and then jump down to the next one. So in this case, once again, I've got my age range, but then gender. So we have male, female, and it looks like maybe one person marked other. And then 0 means no hypertension. So there's quite a few people in this data set without hypertension, 498 with hypertension. So about a tenth of the people. And then no heart disease, and then heart disease. This is the ever married, more people married than not. These are the different types of work types that are represented in the data set. We're pretty split on urban and rural living arrangements, and then these are the different smoking status. So this just gives you an idea of what the range of responses are for each of the different features in the data set. So now I want to look at, I'm looking at this gender thing with this one other. And this is a pretty common thing. Now you could have people who are non-binary would be responding. But because we only have one, I'm just going to drop that one other. And so now I've only got the 2 responses, male or female. Now I want to look at this BMI. This is a case where we've got something called outliers. So the outliers are where we've got, the kind of this bell curve where most of the respondents are in this range of BMI between, say, 13 to, 50 is pretty high. So, but we've got these pretty small numbers at very high values. I'm going to get rid of some outliers here. In this case, I'm saying my cutoff is 50. So I've done that. And then if I run my BMI again, now I've got, the range is now from 10 up to 50. We've eliminated those very large outliers. And now I'm just going to run a bunch of pie charts. I am grouping by gender and then by the stroke, grouping by the number of females who have had a stroke and then the number of males that have had a stroke. Something like this, I found someone else who had made a similar type pie chart, so it wasn't like I had to generate this entire thing by myself. Seeing how other people have done it, it's a good way to generate. So I thought this would be an interesting pie chart. So what we're actually looking at here is of the people that have had a stroke. I'm going to add in a new cell here. And what I'm going to do is I'm going to put this as stroke. Okay. This is just to show how many people in our data set have had a stroke. Looking here, we've got a data set, and only out of 5,110 people, only 248 people in my data set have had a stroke. So that's actually quite skewed. Just going back to what we're talking about here, of those 248 people, 56% of them are female and 43% are male. Okay, so that's what this is showing. So if we look at the value is 140. Out of those 248 people, 140 were female and 108 were men. In my case, I chose to use the Plotly library for my plots. there are other ones like 𝗬𝗺𝗺𝗀, 𝗧𝗶𝗺𝗺𝗀. There's other ones that you can use, but this is the one I've just chosen to use. I think it's pretty simple. And then I looked at by work type. The breakdown is almost 60% of the people that had a stroke worked for a private company, 26 self-employed. So you might look at these things just to see if there's some sort of trends. I mean, it's kind of like the gender, it's kind of split. Slightly more females than males have had strokes. 60% work in private companies, but you might look at, in general, that percentage of people might work for a private company. So this might just be indicative of, a population itself, not necessarily relating to having a stroke. Smoking status, which I think is pretty interesting, that, the biggest percentage of people that had a stroke never smoked. I would have actually thought that was different. So that's kind of interesting. But again, this is that breakdown of smoking. Residence type, slightly more urban people. So does that have an effect on whether or not a person has a stroke? Marriage, 88% are married versus 11%. So maybe you might say marriage leads to strokes. Not necessarily, but again, this just could be indicative of population trends. What I did was I decided that the residence type and the work type I didn't think were that important to the data set and to the model that I want to make. What I'm going to do here is drop those. So this is df drop. Axis means that column by column. So if I drop that, now I do an info. I've now dropped those 2 columns. So I'm down to 9 columns. Oh, and I've also dropped ID, sorry. So now I'm going to do some of my pre-processing. I've done a little bit with removing outliers and removing null values. So this is the scikit-learn library. I've mentioned that in the lesson. If you haven't already, you would have to install it. I would do it in my terminal window. And I've previously done it, but if you haven't already, you can either exit out of this and do it here in the terminal window, or from within a Jupyter Notebook, you can actually put in a terminal command. So you would just do pip install, and it's scikit-learn. So you'd want to install that if you get an error. So if not, it would be installed. Mine's installed so I don't get an error. What I'm actually doing here is the first thing is the label encoding. And what this does is it takes text labeling within a feature and turns it into a number. For instance, 𝗬𝗺𝗺𝗀 is going to be either a yes or a no. What I'm doing here is I'm using this label encoder. And what this does is it automatically looks at the different options or the different values within it. And in this case, I encode it and then I print out the unique values, which are 1 and 0. So that's going to be yes or no. And then what I want to do is the same thing with gender. So I'm going to use this label encoder to fit and transform it. And then I've got gender values of 0 and 1. And what I'm actually going to do is I'm going to add this up here just so we can see what they are before and after. So let me go back and let me run up to here. So I'm going to restart my kernel and run up to the selected cell. So this will redo everything up to this cell because I want to just kind of reset what my DF is, my data frame. So we wait a minute for everything to run through and it should come back to here. Here we go. DF ever married. So that column, the possible values are yes and no. And if I want to do, I could also do DF ever married value counts. And that will tell us that 3,289 said yes and 1,741 said no. So now if I run my, and I'm going to do this again, we can see that the zeros, what the zeros and ones represent. So again, the yes is the 3,289 and the no is 1,741. And I'm going to do the same thing here. So in this case, there with 2,935 females and 2,095 males in this particular data set. And what I'm going to do is run this again. So our 0 will be representing female and our 1 will be representing males. And then we're going to do the same for smoking status. So in this case, we've got a few different options here, not just yes, no, or male, female, but we've got never smoked, unknown, formerly smoked, or smokes. Interesting though, this unknown could be anything, right? We don't really know. So I'm going to encode this, and then what happens is I get the values 0, 1, 2, and 3. So never smoked is represented by 2, unknown by 0, 1 is formerly smoked, and 3 is smokes. I've encoded all of the non-numerical values so that everything now is numerical within our data set. Once you want to create a model, you break it into two parts. X is all your features, which are going to be all our columns, and then our Y is it was considered our target. So in our case, we want to be able to predict whether or not someone has a stroke based on all of our features. So X are the features, Y is the target. We're going to get X by dropping the stroke column, and we're going to get Y by just taking the stroke column. Okay, so we're taking our data frame and splitting it into features and target. And I just wanted to make sure that I had both stroke and non-stroke in my Y, and I do. And now if I do my X head, this is taking just the features. So my stroke column has been dropped, and it just tells me the first 5 rows of it. Once we've got our X and our Y, which is our features and target, now we're going to do our splitting of our data into a training set and a testing set. Again, scikit-learn is great because it provides us with these functions and libraries. We're going to import this train test split function, and then we're going to break it up into 4 different subsets. So we've got X train and X test, Y train and Y test. We say call the train test split function, pass it our X and Y from up here, which is our data set, and then we tell it the test size. So we're basically saying take 80% of this data set, and that will be our training, and then the remaining 20% of our data set is going to be for testing. And then this random state just gives it kind of a random seed for how it splits it up. If we run this, we now have our subsets for training and testing. Now the other thing that we have to do is we have to scale the data so that it's all in the same scale. So here, for instance, we have people's ages, and ages we said range from 0 to 80. Our BMIs range from 0 to 50. Our glucose levels here, though, they go up into like the 300s. And then these ones are going to just be zeros and ones. So because there are some very large numbers here, very small numbers here, we want to scale our values for all of our features so they're on the same scale. It scales everything around 0 so that all the numbers are very close to each other. We're going to import the standard scaler from the scikit-learn library, and we create a standard scalar object, and then we say take the X training set and fit that around this scalar. And then once we've done that, we've got the scalar, and then we can do the same with our test. So we're going to transform that according to how we've scaled it with the training set. And then just to kind of show what that looks like, I'm just going to show the first 10 rows. Whoop. Okay, and now you can see that all the numbers are of a range between, -1 and 1. So it took all these numbers up here and scaled them so they're on this very small scale. And that just helps the model to weigh everything the same. So while I was making this Jupyter notebook, I did try creating models with different algorithms. And because it wasn't performing the way I wanted it to, I did some investigation and realized that my data set was overfit. So what that means is in our target, we have a very unbalanced set. So if we go back up here, if we go back up here to the stroke, it's very imbalanced. So these are the people that didn't have a stroke in our data set, and these are the ones that did. So these you'd want them to be more balanced than they are. This is very skewed. So coming back down here, I did some investigation. I found this library, 𝗖𝗵𝗽𝗀.oversampling, and within that a function called 𝗧𝗵𝗽𝗀. This allows us to take a skewed or unbalanced data set and rebalance it. So just to go through what we're doing here, I import the function, and up here, this line would install the package into my environment, my virtual environment. So here I am importing the 𝗧𝗵𝗽𝗀 function. Just to be on the safe side, we're starting over with brand new x and y. And then we create this 𝗧𝗵𝗽𝗀 instance based on the minority grouping of the people who've had a stroke, which would be, that's the minority in our data set, and then resampled it, creating a new x and y, calling them XSM, YSM, and these are just printing them out, and then redoing our train test split based upon the new x and y that have been resampled. And each of these print statements just gives us some information. So initially, in our original x and y, our split was 4782, no stroke, 248 stroke. We resampled them, and printing out the new y values, it's an even split. So what that does is it actually increases the size of our data set to accommodate this. So it just basically almost doubles it. And then after we do the train test split, it does the 80%, 20% split. And so this is our training set, and you can see they're pretty evenly split. And this is our testing set. So our data sets increase in size, but now our sample is very balanced with an even number of stroke and non-stroke. Now with our new training and test sets, what we're going to do is run that back through the standard scaler. So if you remember, this is going to put it back on a single scale between -1 and 1. So if we run that again, and here's a bunch of imports, and these are some of the different algorithms that I decided to try out. How did I choose these? Again, we want to choose ones. In this case, we've got a classification problem here. We want to classify two discrete values. We've either yes, stroke, no, no stroke. So in that case, we've got just two values we're going to classify for. So we've got a classification algorithm we're looking for, and these are some of the pretty popular ones: logistic regression, random forest, decision tree, and k-nearest neighbors. And then these are some of the functions that will provide evaluation metrics, so accuracy scores, etc. So what I did was I just said, okay, let's go through each one and create the model. So it's pretty simple to create a model. You create the logistic regression object and give it just, again, a random state. So it's just a random variable. We're just going to give it a 0. And then we say fit it and give it the x and the y. So our features and our target. And then we say now predict it using the test data. Yep. And I forgot to run my import first. And now if I run this, okay, so now I've got a model. It's called log_reg. One of the evaluation methods is this confusion matrix. And what this does is it tells you the false positive, false negatives, true positive, true negatives in a little matrix. So if I run this, basically with the test data as well as the predicted data. So what we've got here are the 4 numbers. And what this is true negative, false negative, false positive, false negative. So you can see this isn't great because we do have plenty of false negatives and false positives in our model. And then this is just another metric, which is just a score. And this is from the metrics. We can run that. So it gives us an accuracy score of 79%. On the training set, we get a score of 79. And on our test set, we get a score of just slightly higher. And then what I wanted to do is, try this out with some numbers that I knew should produce a 1. And this is where I was testing for overfitting. This particular cell was, I wanted to actually test whether or not, with numbers that I knew should produce someone as a high risk for stroke. So this is, I believe this is male, 68 years old, no hypertension, heart disease. This is the glucose level. This is the BMI. And the 2 is the smoking status, which is, I think it is never smoked. But that was one in our training set that should produce a stroke in the prediction. So I just wanted to see if by passing that information in to my new model, would it produce that same output? So I did run this. I rescaled it using the standard scaler, and then I tried to predict it, and it returns a 0. So that actually returns that the person is low risk for stroke, which to me wasn't very accurate. So now I said, well, let's try some other different algorithms. So the next one that I tried is this random forest classifier. Again, it's a pretty simple way to create the model. You create the classifier. These are parameters that I just found as good ones that other people have used. Number of estimators, number of trees in the forest, within our random forest, and then there's different mathematical formulas that are used, and so this is one of the options, entropy. And then once again you fit it to create the model, and then you go and predict using your test set and get your predictions. And then what I wanted to do is I wanted to see, does this actually generate both a 1 and a 0? And this was before I did my resampling up here. So before I did that, I was actually getting just zeros in my outputs, and that was because it was so unbalanced to begin with. So now that I've balanced things up, I'm getting, in my target prediction, I'm getting both the possibility of stroke or no stroke. Once again, this confusion matrix gives us some numbers with our false negatives dropping a little bit. If I run my accuracy scores again, we're jumping way up. So that's on the training set, that's expected to be high, but this is a pretty good accuracy score of 92%. Oh, and then this is me again passing in this information to see if I would get a 1 or a 0. And in this case, the random forest classifier returned a 1, which I would expect with those numbers. Then I'm running this accuracy score, 92%, so that's pretty similar to what this dot score metric gives us, and then this is a different one called accuracy score. So we're up in the 90s, which is pretty good. I ran another model, in this case a decision tree classifier, different formula, this Gini formula, different parameters that other people recommend. Create the model and run the prediction. I wanted to make sure I got both 1s and 0s. This confusion matrix, numbers are a little high again on my false negatives. The scores on this one are in the 80s. So far, my random forest classifier is performing the best. This one, however, did return a 1 as I expected from my little test data. Another one that I ran is this k-nearest neighbors, which is another popular classification algorithm. Again, testing, yes, I got 1s and 0s back. Accuracy score, almost 87%, which is pretty good. Again, let me test, does this return a 1? Yes, it does. And then I wanted to play with this cross-validation. So cross-validation, what this does is it allows you to split out your training data and test data in many different ways. And this is a way to make sure that your model is going to perform well, no matter what you train with and test with and how you split that out. Because splitting it out, you might just randomly choose data that's going to lean one way or the other or be biased. What I'm doing here is our K values, we're going from 1 to 31. So I'm really running it 31 times and looking to see which K, which is the number of nearest neighbors, we can pass that into our model, and you can get different results depending on what you choose for your K. So this is a choosing of a parameter by using this cross-validation. So remembering that cross-validation splits up the data in different ways. Each time that you run it, we create these things called folds, and so it splits up the full data set into a bunch of folds, and then each time it iterates, it chooses a different fold for the test data. So this way, each time you're running it, you're training it on different data and testing it on different data. Okay, so it's running. Okay, so it says the best K value is actually 1, and the best score we get is 89. Slightly higher than what I had up above. And this is another way to look at it, is you can take the scores and this will show you which is the best one, which is 1. And then it kind of dips down. Okay, now take the best score that I got and then create my model using that. So I'm creating a k-nearest neighbors model on my best choice for k. This is a way to, choose the best parameter for my model. Okay, and then predicting this, we've got an accuracy score for that of 89. Again, I was just checking my single test data here. In the end, after all these different tests and just exploring the different models, I didn't go too deep. You can go much deeper. What I decided was that my random forest classifier, which was one of the models that I created, had the best. It was up over 90%. So that's the one I decided I want to use. And then the way to export this information, so I'm going to use my model in a Streamlit app. So I want to export my model, but in addition to my model, if you remember, I did that standard scaler where I scaled my data. So when someone's using my app, they're going to be putting in actual numbers like their actual age, their BMI, their, whether or not they have hypertension, heart disease, etc. So all of those are going to be numbers that then have to be, for our model, we want them scaled down to that number between -1 and 1. So I'm going to use this 𝗵𝗺𝗺𝗀 package, which is part of the Python libraries. You may have to install this if you get an error with the import. Go back out to your terminal, or you could do the pip here with a exclamation point in front of it. And then there's this line that just says open up this file, and this is just what I chose to call it, _MDL. And this PKL it's the pickle file, and this is saying write in binary. And then we just saying dump this. I'm going to dump both my model and my scaler into this one file. And that way I can access both of them from my Streamlit app. And we'll see that when we get to Streamlit. But I'm going to run that. And then we should be able to see then that now here in my stroke prediction, I've got that file, _MDL_pickle. So that's what I'm going to use in my Streamlit app. So my model's been created. I've got it in a separate file, and I can use it in Streamlit. That's going to be our next step. So let's just save this, and then let's go out to Streamlit and start to create our web app, our stroke predictor web app.